Hi Tim, this is the follow-up on how to do that mapping, and I'm going to show you an example where we're going to compress a cylinder elastically, and then we're going to restart the simulation, and you'll see it go back into equilibrium. Okay, so I just wanted to go over my initial model here. So I have a part, it's cylindrical. I've done um, uh, like a brick meshing. Okay. And if we go over to assembly, bam, we click on this. This is the mesh I'm starting with. Okay. Now I have a step. It only goes one increment, and that's just going from non-compressed to compressed because it's elastic. It can do it in one step. I have some material properties, and I assign the section for boundary conditions. You can see I have two. One, I fixed this base. I believe it's encastrated or something like that. And then I'm compressing this by 1/10 of its length. Okay. Now I go ahead and run that simulation, and I wanted to point out one unique thing about it. To be able to do the restart analysis where it's mapped from the model, the old mesh to the new mesh, you have to have one thing selected, and that is this right here. So normally restart write frequency is set to 0, which means that nothing's happening, but it needs to be set to 1. 1 meaning thus that every increment it's writing some input. We might select only have the last increment of that initial simulation to do that, and you can select that. You just look it up. Next, I went ahead and ran that, right? And I imported, let's go over this model. Okay. So I imported that compressed cylinder, which I should show you what that looks like actually. Open. So that was from job 1. Okay, so this is what it looks like. Okay, I'm gonna fix those limits so that it's easy to compare. So doing 9.3 E9, and I'm gonna do 0 for the base. Okay. Okay. So what we'd expect is when that on the initial increment that the stress profile would be the same as this, right? So let's go over. We have this model 2. We've done this meshing, or we've converted it to a solid after going through those mesh procedures that we talked about. I put it in the assembly. Okay. I make sure it has all the same material and section properties. I create a new step, and the step is more of a dummy step. It doesn't do anything. But you can see I have time period 1, nonlinear geometry, 1, 1, max 100 increments. Okay. Okay. And then I have boundary conditions aren't translated in this kind of simulation, so you have to specify what you actually want to be there. So I just picked the same initial boundary condition as before, and that's this encaster. So, okay. Now, if you go down here, you right click, you can write the input file. When you write the input file, everything will be ready to go in it except for one thing. What you'll need to do is add this right above the step definition. Okay? Map solution. And map solution you can look up in the reference guide. Map solution is going to take the restart. Basically, it's going to do a restart analysis except it's going to map the old solution onto the new mesh. Now, unbalanced stress So this is saying how it should be handled. So if you just do step, according to the Abaqus manual, maybe here, let's see, according to this, so first off, I'll just go to the top of this. So this is mesh to mesh solution mapping, and this is in the analysis guide, and you can click these hot links to get around. So I'll just go over real quick to this. So you can get, so right now I don't have this specified or this specified, which just means it's going to take the last increment and the last step. These are the two options that you have. You can either ramp the stress back, like the equilibrium, and this is probably what we'll do in the end, but I'm just going to do a step. It's just going to be resolved in the first increment, so that nothing is the problem now. Okay, so let's go back to mesh solution mapping. This gives you an idea of when to, well, that doesn't really matter. Like remeshing contact problem, still nothing important here. Okay, I think at the bottom they gave this input file template. Okay, so you can see pretty much everything is the same as far as the outline, except this map solution is put in. This translation and rotation of data just means that if for some reason we decide to rotate the part or something, we'll never do that. You just have to specify how the solution should be mapped onto that new configuration. But that's completely irrelevant. So the only thing that we really need actually is just to specify this unbalanced stress ramp or step. So you can read about that and just look at stuff. So I've added that in. And remember, if we want to do another step, we need to do this frequency 1 so that we can do that restart. Okay? So now that this is all set, I just went here and I ran these commands. So my job name is equilibrium is what I called it. The old job, that first job that I ran, was called job-1. The old job is just a reference of where the data is going to be coming from, and you need to have that. And then I have this input, and this is my input file, as you see up here. Right? Okay, so going back over here, let's see what we have for an output from running that simulation. Okay, so I'm going to open up this equilibrium, and I'm going to go ahead and do this. Okay, so this is after equilibrium. On an elastic solid, you would expect it all to go back to 0 because whatever you compress is going to completely return. And that's what we see. You can see this 0 and that this all went back to 0. Due to the boundary conditions, this didn't quite go back to 0. But that's to be expected. If I had just picked a point, like right here, for instance, none of that would have happened. Okay, now, the moment of truth. If we go back, I actually need to rerun this because I ran it with the wrong something. I think I had modified it. I had run this with a 9 instead of an 8. So if you give it different material properties, it's gonna scale things kind of funny. So you need the same material properties for everything to be defined properly because there's a history associated with it. So let's go back here. I'm just gonna run this real quick. Okay. So I have Abaqus job equilibrium, old job equals job-1, and input is equal to EQ3 input. There we are. Okay, it's now running. Okay, so looking for equilibrium. You can see it's locked, so it's going through the preprocessor right now. Now it's running. So if you forget to do the restart, this MLD file, model file, and this STT file and stuff won't be generated, and those have to be generated for that map solution to work. Okay, so I should have closed this, I guess. I'm gonna get yelled at here. Or not. Okay, whatever. That. Okay, so looks familiar. It looks like the same as the other one. Okay, so let's this is kind of neat. Where'd it go? Let me create a different one. Go back to viewport 1. For whatever reason, I just lost my other viewport. Okay, I'm not sure what the deal is. Okay, but so this is the new mesh, right? Look at these values. And then we go over to the old mesh. Same values. Very similar. It's the same, actually. I wish I could have just showed it to you, but you can see. It's the same outline. So this has been successfully mapped. Okay, and then if I go, so that's step 0, that's the initial step. So this is what's initially, before anything happens, this is a predefined field. Now if I go from 0, I need to reopen it, I think, because it hadn't finished its simulation. Oh, it is still not finished. Okay, it's still running still. So I'm gonna hit that. So I guess it's just taking a little bit of time to run. Should be done any second. There we are. Okay, you can see how it goes now. See, that's in the compressed state, and it's all elastic. And then we go out, and it's completely returned. So we have successfully mapped from the distorted mesh, redid the geometry, and interpolated onto the new mesh the old results. Well, it's pretty simple. Now, here is my advice. Okay, so when we generate these input files, they're obviously in layers. We don't need to have this start and end assemblies and different things like that. We just need to have the step and end step there. So a lot of this can be removed by an option in uh, the main file that configures all the options for Abaqus. So what I would suggest for automating the insertion of this map solution unbalanced stress step right here is that we have some predefined step, okay? And we take the first, I don't know, however many lines. Maybe we go all the way 3 lines past maybe some keyword like materials or something, okay? So it picks up right here, and then we have this file, and we just write to that file this last section, because it's all, if you look at it, it's all generic. There's nothing special about any of it. Okay? Yeah. So I hope you found this helpful. My time is about to run out in 5 seconds.